So what we are doing today is I want to do the second question in that regard using first principle method to solve differentiation. So the first thing we'll do is that we said to y you add change in y, and to x you will add change in x. We'll be having y adding change in y, and then we'll have x will add change in x, but we will square it because there's a square here. So once we are done, we'll expand this bracket, expand this, expand this. Of course, you know, let's expand this thing first. These are normal algebraic or normal binomial principle. This is double of this. We'll have x plus change in x, and then we'll have x plus change in x. Opening this, x times this will give us x squared. This times this will give us plus x change in x. This time this will give us this, and this will give us this, and so, but then this will give us plus x change in x. Then we'll have plus change in x squared. Change in x plus change in x will give us 2x change in x. So x squared plus 2x change in x plus change in x squared. So we have gotten what we needed here now. Expanded this, we're going to use this to substitute the value of this expansion here. Is that okay? So I'll print it off so that they're able to. Please, can you just capture it? So we are wiping this away. So bringing this to our expansion equation, we'll be having y plus change in y is equal to this, what we have here, x squared plus 2x change in x plus change in x squared. What do we do next? Let's move this so we have the space to solve. So with this now, we subtract y minus y plus change in y is equal to x squared plus 2x change in x plus change in x squared minus y. So this and this will go. We have change in y is equal to x squared plus 2x change in x plus change in x squared minus y. But y is this. Y is x squared. So we have x squared. So coming to this point, this and this will go. So this will be cancelling this. We'll only have this left. We now have change in y is equal to 2x change in x plus change in x squared. Right? What do we do next now? We divide both sides by change in x. Why? Because we are differentiating with respect to x and not to y. So we're going to divide both sides by change in x. So change in y over change in x is equal to 2x change in x over, this is the term we're going to use each time we divide it, change in x plus change in x squared over change in x. So this will cancel this and this will go, remaining change in x. So we now have this 2x plus change in x. Okay, let me claim it. Capture it. So what we have left now is change in y over change in x is equal to 2x plus change in x. So we're going to take limits. In taking limits, take limit of change in y of x is equal to 0. In taking limits, we always take limit for change in x, and it's always 0. It's always 0, it's always 0. So we have change in y over change in x, or dy dx is equal to 2x plus 0. So this is gone. What do we have left? We have change in y over change in x is equal to 2x. Now if you recall that general method of differentiation, you will have your answer as 2x. General method, remember, in our general method, if y is equal to 2x, sorry, x squared, multiply this by this, we have y, dy dx is equal to 2 times x to the power of 2 minus 1, right? So this, we have 1 here, which is equal to 2x to the power of 1, which is equal to 2x. So that's exactly what we'll have here as our answer, coinciding with this. Thank you very much. Please try to subscribe to our video. We'll drop our WhatsApp number. If you want a personal tutorial, let us know. In all aspects of mathematics, just give us the area you want us to help you. Or you want to begin from scratch, you have a child, you have anybody that wants to begin mathematics from scratch, we will take you hands-on until you grasp the entirety of the concept. So that's what we'll have for now. Thank you and see you in the next class. Bye. This is Genesis Mathematical Academy. You're welcome.